Okay, example 8.
Population growth. We were just talking about this.
Yeah.
OMG.
But in this case, we are talking about some populations that will have exponential growth, at least as far as we are
for what we're looking at.
Because sometimes with models, actually what happens is you only look at like
5 or 10 years at a time or something.
Yeah, because it's really accurate for maybe a certain period of time, and then as you go on, it becomes less accurate. So we have this like
PB&J
formula thing that the P0 is your initial population.
Anything 0 subscript will be an initial.
Yes, so P stands for population. So initial population, B is a number that represents the rate of growth, and T is the amount of time, usually in years, since the initial population. So on example 8, using the data in the table and assuming the growth is exponential, what would the population of Columbus, when would the population of Columbus surpass 800,000 persons?
Let me get my calculator.
Okay, so what we need to do is actually figure out at what rate we're growing first, right?
Yeah, fine, great.
So we have an initial population. Wow, you just knocked my armor out.
I'm sorry about that.
The initial
I found food on my
population
desk too.
is 632,910 because that's the first year they give us. And so we're saying that 10 years later, it is 711,265. This is something we know. So if we use this formula, P of T equals P naught times B to the T, we actually know almost all of this information. We know that P of T, which will be P of 10, is 711,265.
I know P naught.
Yeah.
632,910.
Okay. We don't know B. That's what we're trying to find, but we know that this is all happening when they're 10 years apart.
Right.
So we can solve for B.
What?
We can.
Let me just punch this into my calculator real quick.
Divide both sides by 632,910. I'm going to move my work over here.
Yeah, go ahead. I'm still typing in these really long numbers. Oopsie.
It just gave you a fraction.
It did, which was exactly what I typed in, so that's always good. 1.1238.
Okay. More decimals the merrier, right? The more accurate
on this
it'll
one,
be.
yeah.
So B to the 10th is this. So how do we finish solving this?
Gosh, here's what I would do.
Yeah.
I would graph B to the 10th.
Really?
Mm-hmm.
And then
I would graph 1.1238.
And then
I would see where they intersected.
Okay.
What do you think?
Okay.
Okay. So let me just do that real quick. You can graph anything. Right?
Right.
So.
And we will talk in a later section about how to do this algebraically.
I'm actually going to graph
x to the 10th
minus 1.1238. Yeah.
And then you're looking for where it crosses the x-axis.
Yeah.
Which a lot of times is easier to look for. I thought I'd see if I could beat you, but I'm not going to. Okay, so
what's the question?
It asks we need to find B so that we can figure out where it surpasses 800,000.
Geez, this looks like it's going to be close to 1. So I'm going to analyze this graph. I'm going to find a 0.
Find a 0. And you want to find the positive 0 because there's one over there on the negative as well. B equals.
It says 1.01, but I feel like we should get a better
approximation
than that. So I'm just going to change some settings on my stuff real quick. Oh, I had it. Oh. I'm gonna beat you. $1.01174. Oh yeah.
I have no idea what your calculator on your computer. Oh, okay. Look, see, there's the graph. And then if you find this 0.
That's a differential equation on top, on the bottom there, kids.
So
the general solution to a differential equation.
Good times. So that 0 he found using second trace to go down and calculate a 0, and then left bound, right bound. Oh, guess. Yep,
Hey,
1.01174.
That's why did you doubt me?
I didn't. I just thought I'd see it through. So our model is P of t equals P naught, which is 632, 910, times 1.01174 to the t. We want to figure out when does that equal 800,000? Or when is that greater than or equal to 800,000?
So what I'm going to do is I'm going to graph that. And I'm going to graph 800,000.
And see where they...
Or graph that minus 800,000.
Right. We're trying to say that this number right here has to be greater than or equal to 800,000. And so to do that, we can do the left side minus that side and find ourselves a nice, what do you call those? Intercept?
Yeah.
A nice x-intercept.
And I have to change my window here a little bit.
That can happen because we do have some really big numbers here.
Yeah, so I'm just going to zoom out a little bit. I'm zooming out. Oh, there it is. So, wow, this is quite a far ways out there.
Like, what should our x be? Like,
You know,
50?
probably in the 30 to 50 range, yes. Actually, 20. 20 is where it happens.
So I stuck my x
20.07
value
years.
at 50, and so whatever that is.
Right, 20.0729.
Okay.
That's how many years it's going to take. So basically 20 years.
So our answer would be about 20 years.
Yeah, about 20 years.
And a lot of times you'll see answers like that with populations and things like that they'll say, oh, well, it's about this many years.
Yeah.
Because a lot of this was approximating.
Right. And you're not going to say it's going to happen in the 20th year in the month of April.
You could, but you don't actually really know. You're not that certain normally whenever you're doing this
It'll
stuff.
occur during the 20th year.
Right.
Yes.
So that's all there is to 3.1.
Really?
Yeah.
All right, good talk.